So here is the Chapter 4, Lesson 2 and 3 free response quiz question on a plot of land where we have increasing fertility going from north to south. And we have 5 different corn varieties, A, B, C, D, and E. And we want to see what corn variety is best. But we know that fertility increases as we move south in the plot. So the first part is to explain why a randomized block design would be better than completely randomized design in this setting. Let's take a look at the example and get a visual of what we mean by the fertility. Here's the least fertile plots up here that are the lightest green, with the darkest being the most fertile. So that means the soil has more nutrients to allow a plant to grow. So here, that's a lurking variable that would confound our results. We could also call that a confounding variable. So how do we account for that? Well, the randomized block design lets us account for that. What could happen if we didn't use a randomized block design? Let's take a look. Outcome if we didn't use a block design. We just randomly assigned to squares. Now let's take a look at a couple crops in particular. Let's look at crop A. Well, crop A has 1 plant in the least fertile, but then it has 2 in the second most fertile and 2 in the most fertile region. So it's at an advantage because 4 of the 5 are at an above average fertility soil. So we might see better results there that aren't really a result of the type of corn, but where it was planted. You can also see with D that type D has 2 in the least fertile land, another one in the second least fertile, and then the last 2 here. So it has nothing in the most fertile land. So it's likely here that just because of the soil it's planted in, A would look better than D. But that might not be because the plant's actually better. It might be because of where it was planted. So a randomized block design would treat each row here as if it were its own experiment. So the fertility is the same along the row, so we're going to randomly assign A, B, C, D, and E to the row. At the least fertile row, I'd randomly assign, so I'd have 1 of each type of plant in the first row. I would only compare results for this row among this row to see which grew best there. Then I'd go to the second one and randomly assign. And I would only compare results within this row. That way I know that the result is how much it grows as a result of the type of crop, not just due to the soil fertility. So we're accounting for the variability in soil fertility by blocking. It's as if we're treating this as 5 different experiments because the 5 rows each have different fertility. We're controlling for that by just looking at each row one at a time, making sure we have 1 plant in each row. And we'd go on for all 5 rows. It'll allow to control for the variability in the yield due to soil fertility. So we're accounting for the change in soil fertility by planting 1 of each type of crop in each level of fertility. That's called blocking. This will allow us to just differentiate between the type of crop and then the soil fertility. So we're controlling the level of soil, and that's the goal of blocking, accounting for a lurking variable by separating based on that. So it happens before random assignment. We separated by fertility level of the soil, and then we randomly assign within each block, and we only compare within the block so that we're keeping that lurking variable out of it. That would mean we'd use the rows as blocks. That way we'd have we could compare each row for the same level of fertility. If we use the columns, we could still get a widely varying soil fertility. We could still have a lot of 1 planted in the very fertile soil and a lot of 1 planting in the very infertile soil. An SRS. So here we didn't have an SRS, but if we have one, since it's random, it should mirror the population. So since we're randomly sampling, we can apply the results to the population since we have a sample that should be representative of the population. And random assignment should, by chance, create 2 roughly equivalent groups with regard to lurking variables so that we can determine cause and effect. Is the treatment causing the response and not just a lurking variable? So random assignment lets us determine cause and effect by creating 2 groups that should be as similar as possible by chance.